everyone. Myself Sarita. I'm a 2023 MTech pass out from Bechpilani, Hyderabad from microelectronics. So from on-campus placement, I was placed in NXP Semiconductor for the role of physical design engineer. So presently, it's been 1.5 years I've been working as a PD engineer in NXP Semiconductors. So coming to my job role first, when I was hired as an intern for this team, initially my 6 month intern went into STA team. So in STA team, we first initial 3 to 4 months, all was my ramp up, which was complete ramp up based on all these four domains. That is complete physical design, starting from this floor planning, ending till routing. Then I had a little background of how this prime time tool is being utilized to check for the timing concepts of design, how this timing closure things come into picture while tape-out scenario is there. And then when my full-time job role starts, full-time I was appointed in a PDN team. So when NXP came, the basic criteria was no branch specific. All the peoples were allowed, like embedded, micro, and communication from MTech. All three branches were allowed. And the profile, they did not specifically mention that whether it will be analog or digital or physical design. Only given profile was a design engineer. And CG cutoff was 7. Then we had a written test. Written test had around 25 questions. Out of those, 20 questions were MCQs. Those were mostly focused on some RC circuits that we get in gate level PYQs. Then some digital electronics and some VLSI design questions. Those were covering 20 MCQs with negative marking. And there were 5 subjective questions. So these subjective questions were like kind of designing a flip flop or designing a FSM based on given condition. Then one circuitry was given, we need to perform setup hold validation for whatever parts were given in that circuitry. Then a CMOS based question like you have to draw a CMOS based on this number of NMOS and this number of PMOS, certain questions like that. So those were total 5 subjective questions carrying 5 marks each. And one thing was whichever questions we had attempted and whatever people got shortlisted for the interview, we were asked like, why did you attempted that question in that way only? Like there was a resemblance between whatever questions was being asked in written test and whatever interview we were in taken by. So there was a resemblance between these questions. So this was about the written test. Then after 2 days after written test, we got the shortlisting for interview. So coming to technical interview, there was only one technical interview for my case. It was taken by 2 panelists. The first 30 to 40 minutes were taken by first one, and the next 30 to 40 minutes were taken by a next panelist. For some people, HR round was also there, but for my case, HR round was not there. Just the technical round was there, and then directly I got the offer after 1 day. So let us check what my interview was in the first by the first panelist. So the first panelist just interview started with my basic introduction, then why I was interested into VLSI, why particularly VLSI, then why particularly microelectronics. That was a flow to start with. Then my interview started with the basic CMOS questions. So CMOS fabrication flow that we learned in IC fabrication design subject. Those they were only expecting that I should know the flow, how it starts from lithography and all those techniques, photolithography and all. So I just told them the flow, and they were satisfied with that. They did not expect that I will have very detailed knowledge for each and every step. Just the flow was enough. Then the questioning was based on device level physics of CMOS that we majorly learn in first and second chapter from Rabe book, Fundamentals of Digital Design. Those complete detailed physical design, physical VLSI design questions was asked based on the CMOS. Then I was given a scenario to generate a pulse digital circuit. So for that question, I was given 3 4 scenarios. Like you need to use 5 number of inverters and 6 number of NOR gates, or 2 number of discrete and 3 number of discrete. Likewise, 2 3 scenarios were given, and I was asked to generate a pulse generator. Now there is not a single design to design this pulse generator. So what I was asking is, you take whatever time you need, but based on the given criteria, you at least give us 2 set of circuits. Like if the criteria was like you use 2 number of inverters and 3 number of NOR gates, you at least try to generate in a two-way and just explain how did you come to those particular ways only. So that was kind of analytical question for me. Then after that, that also took around 15 to 20 minutes for me because suddenly when we are thrown a question which is not very familiar, it took analytical time and that was given by them. No issues with that. Then whatever answers I have given, there was some cross questioning based on those circuits I had used. Then there was a question like I was asked to draw CMOS circuitry, then exchange the PMOS and NMOS. Then they had given certain waveforms, and I was asked to generate output. If I changed NMOS to this number and PMOS to this number, based on that, how will the output vary? Those questions were asked. Then few questions based on RC circuitry that we get in gate level PYQs. Like certain number of resistance capacitors were arranged in the circuitry and two C switches were there. So like if first switch is open and second and third are closed, like what will be the voltage on capacitors and all those kind of questions. Those took around 10 to 15 minutes. Whatever answer I was giving based on that, my next question was popping up. Because if they felt like my answer is going in the wrong direction, they will be coming with a cross question why you're going or why you're solving in that way only. And whenever I was like doing a wrong analysis, they were just giving the hints. Okay, this should not be in that way. So no need to worry if such scenario comes. You just let them know whatever approach you are going to. They will definitely guide you like, okay, we are going in the wrong direction or we are going in the right direction. No issues with that. So this took around 30 to 40 minutes, my first half. Then on second half, my second half of interview was completely based on my projects that I have put in my resume. So my main two projects were on low power design. So and the manager, sorry, the panelist was asking me was also from the same domain. So we had a deep discussion on those low power techniques in my second half of the interview. The interview started with like I had implemented two different techniques in my two different projects, which are used to basically reduce the leakage drop in the lower node design. So interview started with like what is low power technique and why are they very crucial at lower technology nodes, specifically below 20 or 30 nanometer. Then I was asked like whenever you're trying to implement this technique, before that what techniques were already in practice, what were the flaws that are being encountered in the existing techniques that we need to look for the updated techniques? Those questions was asked. Then in random, whatever existing techniques are there, about those I was asked like before coming to this project, whatever analysis I have gone through, I was asked why you specifically choose that technique. What you feel like is being wrong in the existing technique, and you need to switch to that technique. Then advantages of whatever I had implemented, disadvantages, and then up to which nanometer this technique can be implemented. Then cross questioning was happening like if I'm not going in this way and if I'm not implementing this technique in my design, then what will my design suffer through? And how will your technique in my design will help me to optimize my design in terms of power and all those kind of questions. Then certain techniques in low power like power getting, clock getting, multi-VT transistor, all those techniques we had discussed, and their variation based on power and delay. Like if the power increases, how will it affect delay? If delay got increased, how will it affect power? And then a main question was detailed classification of power dissipation technique. Like major classification is static and dynamic. Then comes their subcomponents. So all these components are very crucial when you do IR analysis in the real world scenario. So they are not expecting that we will have very deep knowledge, but at least we should know the broad classification and the components, major components coming static and dynamic. So I was asked based on those components, how is the power delay parameter variation in all those four types of components in power. Then certain questions on short channel effect, like when is a channel called a short channel? When the channel is short, what are the certain effects that needs to be taken care when we are working in lower nodes? Then leakage current, I was asked to draw a CMOS inverter and then to draw all the leakage current that are in the device physics level, to draw the electron and holes movement of those currents that are being occurring inside device physics level. And little questions on that were just basics. If you prepare the CMOS structure very well at physics level, that will be enough to answer those questions. And then some questions on multi-VT transistor, like if we are rather than implementing all these techniques, if we try to include multi-VT transistor in the same chip, Will it be possible? If yes, why are we implementing the other techniques then? And if not, why it will not be possible to use multi on single chip? Those kind of cross questions. Those were just to check like how fluent I am in whatever I'm putting on my resume, how much knowledge I have based on whatever techniques I had implemented. And then the last question was based on CMOS latchup. So CMOS latchup, I was asked like what is the thing. I was asked to explain everything by drawing the diagram and showing the flow of charges and how that CMOS latchup can be avoided if it is not taken care into lower node design. How will it affect the overall performance? And yes, these were about the second half of the interview. Yeah. Okay. So for PD roles, you should have something. If you are okay with layout-based projects, go with that. Or these low-power techniques, there are many more research paper available on IEEE and certain sites where you can grab one book paper, you can study the low power techniques that are being implemented or that have been described in that, and you can take any particular circuit, let us say MUX or whatever circuit that we are implementing using CMOS, and you can try to incorporate that techniques from that research paper into your existing design, and then compare like how is the flow going, what is the design, how was the design parameters looking before implementing that, like let us say we took a mux. So actually mux is a simple design using CMOS. Then you had one technique which is used to reduce the leakage power. You use that circuitry and implement that, incorporate that in our existing mux. And then you compare the power delay of both the circuits. Then you analyze like how is this newer technique helping me to reduce the leakage or helping me to improve my power delay performance. Likewise, you can choose the projects that will surely highlight you because lower technology nodes is mainly focusing on reducing leakage. That is a major concern going on. So if you are having something regarding to that on your resume, it will surely stand out. Coming to written, certain common sources that everybody uses, the same even I have used. For digital VLSI design, I refer to the rubber textbook that we are using in the coursework, the same, and Janki Raman NPTEL series that was useful. Just these two things were enough. And then for digital electronics, Morris Mano, I see everyone refer the same. Uh, After Morris Mano, DGQS and gate level MCQs, that was enough. Then for C programming, I referred MCQs, not MCQs, gate level previous year questions, and majorly focusing on pointers, arrays, and structures. For that, I referred Geeks for Samir Palnetkar book I referred, and Bits HDL website for practicing those basic simple questions. And then when STA comes into picture, I yeah, only that website. What is that? VLSI expert website. Only data expert. That was like pretty enough. Nothing much more than that was being asked in the interview. And coming to specifically physical design, while we had a course in our regular curriculum, physical design, for that we had referred, we had a pretty good duration of 2 3 months. So it was enough to go through a textbook. So for that, one textbook or Markov was there, like physical VLSI design from graph partitioning to time closure. So during our course was ongoing, at that time I had used this book, and then while preparing specifically for interview, there are some websites like VLSI Junction website. It is very good for physical design interview and some basic stuff. And another website is vlsipd.blogspot. So these two websites help me very much for preparing specifically for this physical design interview questions. And also apart from this, I was active a little bit active on LinkedIn. So in LinkedIn, some industrial professionals, those are like having a very good experience in this physical design domain. So they usually post whatever their experience is, or they keep posting certain stuff which is really important for freshers. So there were these two people called Savata Bhattacharya and Kiran Bhaskar. So these two people had posted very nice stuff and very detailed understanding of physical design stuff. So I had referred those two posts from these two people on LinkedIn also. So overall, these key components like this textbook, these two websites, and some fewer posts from LinkedIn from these two people had helped me a lot in this physical design. Now coming to my suggestions if you are looking for the physical design role. So as I have said, like there will be major four domains: PNR, STA, PV, and PDN. So specifically to PNR, you should have basic idea regarding how this netlist to GDS flow is there. You should know those all those steps. Then flow planning, placement, routing, and all those techniques. How just an idea of which tool is being used to perform all those flows. What are the inputs required at all those stages? And after performing the flow, after the EDA tools works on those flow, what is the output we get? Now, physical design, all the inputs we give in the form of input collaterals, which are nothing but the input files. So there are a lot of files which has extension like def, lib, TWF, spef, and many more. So as a fresher, it is expected that you should at least know the long forms and what is the content of that file. Like let us say if lib. So what is .lib stands for? At which stage in the physical design flow it is being used as an input, and what are the contents present in the lib? Not more than that. These three parameters for all the file formats will be enough. Then you should have a basic layout based knowledge like what are the layers, how does the resistance of layers varies when we go from M1 to M length, that is from top layer to bottom layer. When we how does the resistance vary? Then when we change the length and width of these layers, how does it affect the delay and resistance? These things you should know only, not very deep, but just an introduction to that. Like if you are being asked for a particular PNR role, then they will expect that you should have this knowledge. Then after that, certain uh, routing techniques like global routing, local routing, and then after routing comes congestion into picture. Like how will congestion happen if you are not taking care of routing? What what feedbacks can be not feedbacks actually, what optimization can be done in your routing to avoid congestion? Then crosstalk, you should have idea about how crosstalk is occurring. You should have idea about terms like placement blockages and routing blockages, just a basic intro. Then types of cells. Yeah, this is an important question. Like, there are a lot of cells being used while we design a layout, like tap cells or end cap cells, pillar cells, and very corner cells, lot of cells. So you should at least have idea like which cell is preferred to use and what is the cell, its internal structure and all. If you know, it is well and good. But even if you don't know, you should at least know like where is the cell used. Like end cap, the name says it's an end capacity cell. So likewise, you should just know one two lines about every cells that are being used. Then HVT, SVT, LVT, that is an important question. You should know these three types of cell and in which type of design which cell should be preferred. That if you know, that will be really beneficial. Now these all things will be majorly required for PNR. If we come specifically for EMIR and PDN, that is EMIR and TV roles, then you should have a very good knowledge about these low power techniques which I mentioned in my second half of the interview. You should have a deep knowledge about those power dissipation classification, static and dynamics, and very detailed knowledge about whatever is coming into that hierarchy. Then after that, you should know what is IR drop, why it is a major concern at lower technology nodes. You should learn like how if IR drop is increasing above our certain limits, then how will it affect the other conditions? Like let us say if IR drop is huge, it will definitely impact our timing. So you should know the relation between if IR drop is occurring, how will it affect timing? Will it be affect in a positive way or will it be affect in a negative way? Then if IR drop is coming, but at least certainly they will not expect like you should know a very real time scenario, but just a normal questions like what can you do to improve your techniques that will ultimately reduce your IR drop. Then certain terms like electromigration, ESD, electrostatic discharge, and antenna effect. You should have a basic idea of those stuff for PDN. And lower technology nodes in general, whenever we refer for some good VLSI blogs and all, when we come by reading those lower technology nodes, so we should know like what are the main areas of concern that are being faced by industry right now while designing in very lower power technology nodes. So that is a basic question. They might come up with a question like, okay, what do you know about lower technology nodes which are very trending nowadays? So it's better to prepare for that question. And then coming to physical verification, you should know the terms like DRC, LVS, ERC, LEC, at least the long form and what checks are being performed in those particular things. That will be enough. And low power techniques like power getting, clock getting, voltage scaling, and multi VTCs. At least these three four techniques you should have a good knowledge. So that if next person is asking you, whatever techniques you know, just explain. So you should be able to at least justify with one, two statements like what are these techniques about. Now, this was about PDN and PV. Now, third comes into picture STA. Now, if a company is specifically looking for STA profile, you should be aware of the setup fault violations. Even a nice circuitry, you should be able to calculate the setup fault equation based on that. Is it violating or not? If it is violating, what can be incorporated into the existing circuitry so that these violations will be gone. Then certain things like crosstalk, timing paths, false paths, multi-cycle, everything is covered in that website. Just go through that website; it will be covered, covering everything. Then specifically focusing on certain topics, you should know metastability, you should know skew, slew, and all the various types that are coming into picture. And you should have idea about synchronizers and clock divider circuits like certain questions maybe you have given a frequency and you need to generate a circuitry which will divide that frequency f by 4, f by 2. Likewise, you should have a basic idea about synchronizer, what are the synchronizers, basic idea about metastability, what is this concept, basic idea about OCV and direct. Yeah, and cell delay, net delay are very basic questions again, and TVT conditions because these all things are basically required only for specifically SPA, not for other profiles. But even if you are preparing as a PD role, it's better to have idea of all these concepts. It will help you in further role. Yeah, this will be enough for the PD role at the fresher level at least. Yeah. Almost whatever I could give for physical design, if you are preparing for, I had given. Just for some interview tips, some people think that we'll be putting very critical projects on the resume. It will pop up in front of the panelist. It's nothing like that. Whatever you are putting on the resume, just be 100 not 200% sure about whatever you are putting on the resume. If you are not very aware of the projects you have done and you are still putting in your resume and if panelists come and asking you questions little bit advanced compared to your project, it will not give a good impression. Whatever you are preparing, just put that only. And yeah, physical design is a very interesting topic. If you prepare it with interest, practically it's a visualization word because whatever chip we are actually getting in our devices, we are doing the same fabrication of chip in computer. The same stuff TSMC is doing in real world, we are doing the same stuff in computers. So yeah, it's an interesting field. Prepare well and yeah, go for physical design. It's interesting. All the best to all the freshers who are preparing.